This video is on the objective determine the p-value for a hypothesis test for the difference of two means. And this is with the population's standard deviations unknown. Right, so that means that you're going to be working with the student's t-distribution with so many degrees of freedom. Right. And let's take a look at this first question. Alright, so if you're unfamiliar with the topic, want to see more about what they have to say on it, please click on More Instruction and look at their videos, their notes, their examples, and hopefully those help you. Alright, so here a pet food manufacturer has a facility with two lines that blend, can, and cook cat food. Nolan Monroe is the production manager of the facility and curious whether there is a difference in the mean number of cans produced each day by two lines, say line A and line B. Nolan randomly selects 300 daily production reports, 141 of which were from production line A and 159 of which were from production line B. The sample statistics are shown in the table below. Right, the sample coming from production line A, the sample mean and standard deviation coming from production line B. And we're asked to let mu1 be the population mean number of cans produced per day on production line A, and mu2 be the population mean number of cans produced per day on production line B. Alright, Nolan assumes the population standard deviations are not equal. Alright, if you assume the population standard deviations are not equal, that means you're in that non-pooled scenario. Alright, and the number of degrees of freedom for your t-distribution and the way you calculate the test statistic, right, all that would be different than the pooled situation, if you assume they were equal. And test the alternative hypothesis, that mu1 minus mu2 is not 0. In other words, that these two averages, the average number of cans produced by both lines, are not the same. Not 0 when you take their difference. Now this is pretty nice of them. Again, the objective is only on determining the p-value. So we are told the test statistic. The test statistic for these two samples, the difference in their sample means, is negative 1.93. And the number of degrees of freedom for the t-distribution for the difference of sample means is 140, right? Which is, because it's a non-pooled, right? Remember, without the number of degrees of freedom they used was the smaller of the sample sizes minus 1. So the smaller of these two sample sizes is 141 minus 1 is 140. Now if it were pooled, right, if they assume the population standard deviations were equal, then it would be the sum of the sample sizes minus 2 for the degrees of freedom, right? But we're using the smaller of the sample sizes minus 1 here. And then they're asking, what is the p-value for this hypothesis test? Alright, so remember, to determine p-value, I need to know what kind of a test it is. Is it a left-tailed test, a right-tailed test, or a two-tailed test? And I need to know my test statistic, right, which they've given me all of this. Right, the null hypothesis would be that mu1 minus mu2 equals 0, right? You'd be assuming that. The alternative hypothesis was given, right, that mu1 minus mu2 was not 0. And if that's the alternative hypothesis, then this is a two-tailed test. All right. And that'll tell us how we're going to need to find the p-value. Alright, now they didn't give us a significance level here. So we would usually just assume 5% if they don't give it to us. But they gave us also a test statistic, right? The test statistic for the difference between our sample means in this problem is negative 1.93. And they also told us that the distribution of the difference in sample means, the distribution of the x1 minus x2 bars, is a t-distribution with 140 degrees of freedom. And I will draw this. So horizontal axis represents, t-scores. Got a symmetrical bell-shaped curve there. The t-score under the peak, right, is a t-score of 0. And then our test statistic is negative 1.93. Right, there's our test statistic. Now, if you want to calculate p-value, and this is a two-tailed test, this is to the left of the middle, so I take the area to the left, right, the left tail, and then double that. Or equivalently, you could take the area to the left of negative 1.93 and then use the symmetry, create a second tail, go to t equals positive 1.93 and take the area to the right of that. All right. But the p-value, the p-value is, this area times 2, right? This area to the left, and again, times 2, or you could say the area to the left of negative 1.93 plus the area to the right of positive 1.93, which would be the same because it's symmetrical. Now, I can find this value, if I wish, on my calculator. All right, remember how to find area under a T curve. So I'll pull the calculator up. Now this is a TI-84 plus. You go to that second distributions above the variables button, and we're finding, don't use normal CDF. That's for area under the normal curve. I go down to TCDF, right? That was for areas under a student's T distribution. Now this area here to the left of my test statistic, to the left of negative 1.93, there is no lower value. So I'm just going to put in some big negative number like negative 99,999, whatever. The upper value is my test statistic of negative 1.93. And the degrees of freedom they mentioned was 140. Right, now if you have an older one, you might have to enter it like this with lower value, comma, upper value, comma, degrees of freedom. Alright, so this area, is approximately 0.028 if I go to 3 decimal places. So that means this area is as well in the right, to the right of positive 1.93. So then put them together, or just double one of these areas, and you're getting the p-value. Alright, so I'm just going to go times 2 in my calculator. Times 2, because it's a two-tailed test, and our p-value is approximately 0.056, right, if I go to 3 decimal places. Alright, and let's see which of the choices that fits into. It's between 5 and 10%, right? It's between 5 and 10%. So down here the choices, the p-value is between 5 and 10% I'm seeing here. That's the only one that makes any sense. Now you could have also done it with this table. Go to that row with 140 degrees of freedom. And look for, now they gave us the negative version, negative 1.93. Look for where would positive one, these are all positive values here, so where would positive 1.93 fall between? And it falls between these two, right, 1.656 and 1.977. So that means the area to the right of positive 1.93 is between 2.5% and 5%, but then you double it because you also have to have the left tail. So the p-value would be between 5% and 10%. So if you're using the table like that, you'd still end up with the same result. I don't know, you could use a calculator as well and actually find the p-value, right? We said the p-value was 0.056, which is definitely between 0.05 and 0.1. So reading the table, using the calculator, either way is fine. And that's all we're asked to do, I believe. Yeah, before it goes to another question. So hopefully watching me write that out. And you've seen p-value before, right? The finding of the p-value is no different here than it was for a one mean t-test. Right? You just have to know how many degrees of freedom and what's the test statistic. And also, what kind of a test is it? Is it left-tailed, right-tailed, or two-tailed? And that makes all the difference. Alright, so hopefully watching this helps you out, looking at the more instruction, reading your answer explanations. And hopefully all this stuff helps you out when you work on this on your own. And thanks for watching.